Okay? So they're saying here, write each of the following using what form? So the first one maybe that we can do, it's page 65. So they give you here, 26 is a series, right? 26 plus 23, plus 20, plus 17. I believe it goes down by 3. Yes?
14, 11.
What is the last one?
So
Did I say, really put 9 there?
it's 8.
Plus what?
5.
Okay, so we determined this is a arithmetic series.
You can see it.
According to you, you can see. First term is 26. The common difference is going to be negative.
3.
Is it true? This minus that. Happy? Are we happy? Are we happy now? The number of terms 1, 2, 3, 4, 5, 6, 7, 8 terms. Are we together?
Yes, sir.
There are 8 terms.
The last
Good. The only thing we need to find, because we know it's an arithmetic series, we need to find T sub
we
n,
know the last
where we have.
We know the last one.
Okay. The question says, the question doesn't say find the sum. We're not interested in finding the answer here. I want you to take this and write it in sigma notation format. Does that make sense? Please answer the question, right? I'm not interested in the sum. You follow what I'm saying? Alright? I want you to rewrite it in sigma notation. So you first identify your first term. If you now determine whether this is an arithmetic series. In the contrast, it could be a geometric series. When it's a geometric series, do not use the wrong T sub n formula. So there is only one T sub n formula for an arithmetic series. It's a plus in brackets n minus 1 times d. This is going to be your general formula, right? So this is what we are looking at when we are solving this, right? So this is what we are going to put down here. We know that it starts where? Well, our formula was an n in it, right? And we know again there is what? There is 8 terms. Do you understand that? So now I just have to find my T sub n. So the T sub n, this is here. Then you're going to put in brackets. It's coming from here. Does that make sense to you? Okay, so a is 26. And n minus 1. Let me just go ahead and put my d in front. My d is negative 3.
Yes.
The plus and minus can be confusing to you, right? Okay, let's just make sure that we leave it. So that I don't put minus there and people wonder. But where is that coming from? So that's 26 minus 3 plus 3, sorry. Because minus what?
Yeah.
Alright, so generally now, it's 29 minus 3a. You can put the minus 3a in front. It's not that clear, but we like it this way, right? Don't like negative terms in front. So this is where we're going to use 29 minus 3a.
General formula.
That's all that you are supposed to. Does that make sense?
Yes.
Write it in that form. I am not saying find the sum. So you have sigma, T sub n, start n.
Easy.
Okay?
Easy.
Okay. Now let's look at 2. Question 2a. You have I guess the reason why I really want to do this one here is because it says 245 terms. Same thing, I'm just going to get right to the answer. So, is it an A arithmetic series or geometric series? The 45 will come here. You follow? Right? That's what I mean by that. Two, so many terms. That's the same like here I have to find a number of terms. I simply count them. Do you follow? Do you know? Here I have to find a number of terms by counting them. But here they're saying the series blah 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 2. So the next one says 2 p terms. That p comes on top. This is part B. You understand? That's all. There is a difference here. Okay, so is this an arithmetic series or geometric series? You're saying arithmetic series?
Yes.
So if it's an arithmetic series, A is equal to 2, and D equals to 2 as well. That's 4 minus 2, or 6 minus 4. So once we are now finding our T sub n here, I'm going to use n because n is going to be in my T sub n formula anyway. Is it not so? So you don't get a mark for that? Okay. He says, I must put another letter.
Okay.
Since he likes to play with letters, I'm going to change the letters to nothing but what? To K. Please don't get confused. It's a valid thing that he raises because don't assume that for everything that you're doing when it comes to the summand or the general formula, it will always be given to you in terms of N. It could be any other letter. I, J, it must just correspond here. J equals, so here I have K equals to, obviously I'm going to start at 1. Alright? Because we're starting there, that's the first term.
Yes.
Okay? First term is 2. You don't write a 2 here, please. That's not what this is. You understand?
Yes.
Because once you want to find the first value, you're going to substitute that first value into your general formula.
Yeah.
So again, our A is 2 plus our K is 2. So I'm just going to have 2 plus D. Does that make sense? Does it make sense? Now you see there you get confused again. Our K, which is the number of what? Remember it's N now. Good. Our K minus 1 times 2. Are we not confused anymore?
2K.
We are not confused anymore.
It's 2K.
We are not confused anymore. It's 2K. That's all it does. Alright, so we're going to multiply that over. So it's going to give us 2 minus 2
plus 2K.
So the final answer is just K.
2K. I said 2K.
Okay. Just want to see that you're not sleeping. So the general term is 2K. If it was N, it would have been 2N.
If you substitute the
So 45, I'm just rewriting it, of course. K equals to 1. Okay, so it was N to N. And surely it's true. I mean, 2 times 1 is 2.
then to the, yeah.
2 times 2, 4. 2 times 3, 6. And so, and so.
You must
But we want the answer in this.
standard procedure.
You get it? Sigma notation. So once you're given the sequence, and I'm going to repeat this because I don't want you to ever forget this. Once you're given the sequence, it says 2 so many terms. Whatever is after that comes now, obviously the end on the limits of summations here. It's the upper.
Even if it's K or something.
Even if it's a K, even if it's a P.
Yeah.
You understand? It's not always that you're going to be given things that's straightforward like that. Okay, so let's look at that second example. They are saying, take the formula of the series 3 plus 11 plus 19 plus and so on and so on. 2. So that means here P comes in. This is small letter P. You follow? Right. Now we need to do 1 or 2 things. Is our sequence here an AP or a GP? Obviously it must be an AP. It's an arithmetic series with 11 minus 3 being the same answer as 19 minus 11. What is 11 minus 3? Oh, okay. And what is 19 minus 11? Good. So it's an arithmetic series with first term equals to 3.
Yes.
With our common difference or constant difference sometimes.
Common.
8. How many terms do we have? P terms. But not necessarily. I know. Not necessarily. So when I ask how many terms do we have,
It's at the end.
top. I'll just write it here. Top minus
bottom.
bottom
Plus.
plus 1.
Yeah, go.
Top P minus 1
Go against.
plus 1. Final answer? P terms.
Against.
I get it.
Yeah.
How many terms here? 45 minus 1 plus 1, 45 terms. Anyway, we are going to find the formula, our T sub n, because this is arithmetic problem. If it was geometric, then you must know it's A R n minus 1 power. Okay? So, we're going to have to start here. I'm going to leave it with n. Okay? So, whatever I'm going to have is n. So, let us just substitute T sub n. It's going to be A, which is 3, plus the common difference is 8, so I can put it in front of my bracket. Is that fine with you?
Yes.
Or unless you have problems?
That's fine.
Please don't just take it like this and write it there. Simplify it, no?
Yeah.
That means you're going to multiply out. So I've got 3 minus 8 plus 8n. So final answer is 8n plus 5. Does that make sense to you? So therefore, I'm going to have here
So minus 5, sir.
minus 5. 8 times n is 8. 8 times that is minus 8. I think the majority of the learners in your class, they went to sleep.
How do you mean, sir?
Are we happy?
Yeah, it was.
So this one is still the same, it's just here. 3 minus 8. 3 minus 8 is what? 3 minus 8 is negative 5.
Negative minus.
So 8n.
So we can provide you
So that's what I was looking for.
in terms of the
So when it says to so many people. Now here's the problem now. The next question. You don't know how many terms there are, but you know the last term. And since you know the last term, that becomes T sub n. That means we're going to find the number of terms. But we must first determine whether that sequence is an arithmetic or geometric sequence. Or series. That's fine? Already here.
we know the last
Uh,
we don't know the last
the last, there are 3 questions there. I'm talking about question 3. You don't see that?
Oh, you're talking about that.
No, we're done there.
Oh, no.
Right. Whether you think there's still something you want to do. What is the sequence there? It's what? Is it not 1 over 3? Also 3 plus 1. Plus 1 over 3. Plus and so on and so on. Plus
I can see it.
1 over 8 into 1. You can see powers of 3 here.
GP.
It's a GP, né? It's a geometric
Series.
Series. First term, 3. Common ratio, 1 divided by 3. 1 divided by 3.
Yeah.
Or distance divided by common ratio. Always calculated by taking term 2, term 1, or term 3, term 2, and so on. Right? So in this case, our common ratio is 1 over 3. Right? Do we know what the last term is?
Yes.
T sub n equals last term equals. What is T sub n for a geometric series? T sub n is a r n minus 1, right?
Yes.
So our first term here is 3.
Yes.
Our r is 1 over 3. N minus 1. Because we are looking for the number of terms.
Yeah.
Okay? Number of terms? Listen.
Divide the
No, we can divide and so on and so on and so on and so on. Okay? We are multiplying. But let's do that because I've seen that people are struggling with the normal arithmetic. So what he says is, because I was not planning to make 3 to the negative 4, all the bases the same, you follow. But anyway, it's 1 over 3 raised to the n minus 1 power equals to 1 over 81. Then I'm going to divide that by 3 because you have this 3 here.
yes.
But this is the same as 3 raised to the power negative 4 divided by 3 raised to the power of 1. Are you with me? Which is the same as 3 raised to the power negative 4 minus 1, which is the same as 3 raised to the power negative 5. This one here is the same as 3 raised to the power negative 1 raised to the n minus 1 power.
I see what it is.
You see what I'm doing here?
Yes.
The negative 1, n minus 1, you're going to get
Negative
1 minus n. So this becomes 3 raised to the power of 1 minus n.
Negative n plus 1.
3 raised to the power of 1 minus n.
Yes.
Drop the bases. 1 minus n equals negative 5. Now find the value of n. N is equal to 6. Final answer. N equals to 6.
I see what it
Is
is.
that clear?
Straightforward.
So take that one over, it becomes minus 6 divided by negative 1.
Oh,
Now
yeah.
we know the number of terms now. So our number of terms now is what? Is 6. So now we can write it in the notation. So our notation becomes,
6.
on top here, 6. Understand? So n equals to 1. Wait, we don't have t sub n. We have it, right? It's here.
Yes.
So 3, 1 over 3 raised to the n minus 1.
Straightforward. Nothing difficult.
Okay. Naturally, I will not maybe confuse you. I probably won't put this square bracket there, but I'm just doing it anyway because we like you to consider that that is one general number. Okay. But in this case, I will not put it because it's too much and can be confusing. And also, it should be a bit smaller than the way I'm writing it here. The sigma notation is supposed to be a bit bigger. You understand what I'm saying?
Yeah.
You get it? Because this is an upper letter, uppercase letter in the Greek alphabet. It's a capital letter. While what you have here are small letters. Does that make sense?
Yes,
So
sir.
you get it?
Yeah.
We're not asking you to find this number. Question just wants you to write in sigma notation. So you must be a bit careful with the book, but you must work through the stuff that I say. Otherwise, when you get stuck, you highlight it, bring it to class. Don't let me be the one assuming, okay, they don't know this. Okay? Because I was skimming through when we were on lunch, and then I was checking, oh, this question. Because it's exactly in that textbook. So everything here is there. Okay, so we are now going to determine the end product. So page 65, line now 28. I believe that's the last part of this stuff. Sigma notation. Okay? So while he's thinking about it, so I want you to take notice here. This is exactly the same stuff that I was doing when I was giving you the first 3 questions in the beginning here. But now we just look at a few of them. But I'm also interested in the inequalities. Again, once you are dealing with sigma notation, think of S sub n because it's basically the same thing. Everything is sum. Everything is sum. You get it? Alright? So you need to know your formulas. Alright? When working with this, obviously, we need to know S. Whether it's S sub n dealing with arithmetic sequences, not sequences but what?
Series.
Or S sub n dealing with
Doesn't matter.
there goes my child again, what does he say?
Doesn't matter.
But let's suppose for here we know that r should never equal to 1, otherwise it's not a geometric sequence. Because it comes 0, divided by 0 is not 4.
R should be less
For
than-
this one we tend to like when what?
R is less than 1.
When r is less than 1. It's the fraction. For this one we tend to use when
R is
greater than 1. Because it's easy to say 2 minus 1, for example, than to say 1 minus 2. You follow? But ultimately does not matter. That's why some instances we just tend to use 1. You follow? So you don't really need to memorize this. Just use anyone. Use this one. Forever and ever and ever. When r is bigger than 1 or r is less than 1. As long as r is not equal to 1. Does that make sense? And when you're dealing with questions like simultaneous equations, like what we did with series, you must just be careful. Sometimes you want to find a ratio, but then they say find a positive ratio. So it means you're going to have an instance where it's geometric, it becomes quadratic, and then you must choose which one to use. If they don't, then you will have 2 pairs of sequences, with one value of r being a positive ratio and the other one being a negative ratio. And then you may be right to do stuff. Okay, so this is what you need to know. You also need to know to find the general term here. You need to know your T sub n. So you have to use T sub n as well. So T sub n here for arithmetic And this one's this side here, they become what? Geometric.
Series. It's N.
So here, T sub n is A plus n minus 1 times C. This comes here. Here, T sub n becomes A R n minus 1 power. So basically, all the formula that we have been covering is used here. But the next thing after we step off from this sigma notation, we are going to work with sum to infinity. And we are only going to focus on the geometric series. Okay? Because it still involves sum to infinity. It still involves sum, but now we are going to infinity here. Infinity here.
Getting closer to 1.
Good. And start. So when you were probably skipping and scanning through your book and you were looking at this funny symbols, you were like, what the? How do you? Nothing to be ashamed of. Greek alphabet, that's one of the first things. Sum, it refers to sum. Things are being added. Other way it does it with sequences. So adding terms. What type of sequences do you know? Arithmetic or geometric. That's all. You must just apply the right one at the right place. Once you are dealing with inequalities, be very careful when you're dividing by a negative. If it's logs involved there, because if you're looking for any, you have to use logs of indices. You understand? Then, or exponential equations or whatever, then your knowledge of exponents or logarithms is very important there. Just be careful, inequalities and changes. And then it should be straight forward. Now, here, they are saying, find the value of n. So I'm going to take one randomly, maybe starting with this one here. P equals 1, and obviously this one has to have a P. So it's a half P minus 1, but it's equal to 7 and 63 over 64. So what I was doing before when I say equal to 24, this is exactly the same thing. We know what the sum equals to, but we have got an unknown here in our generator. Okay? So, first of all, it looks like a duck, walks like a duck, so it is a duck. What am I saying? Is it a GP or an AP?
The GP.
You have to determine that, okay?
Yeah,
It looks like a GP, so the assumption is it is a GP. That's what I'm saying. But don't just go for looks. Test first 3 terms. Follow. Right? So we're going to take the first term, then the second term, but adding, and then we see, is it an AP or GP? Once we know it's an AP or GP, then we go and use the A sub n formula for that. But what is our A sub n going to equal to? Here, this answer. Does that make sense?
We find
Step number 1, we find out whether it's an AP or GP by substituting for 3 values. Once we know it's an AP or a GP, then we use A sub n formula because we already have our T sub n, the general formula is given to us. Just because the general formula in this case looks like this does not mean it is a geometric sequence. So what I'm saying is don't assume. Don't be lazy to do this. 4 times a half, 1 minus that. Plus, it's series, it's a sum, right? Please don't put commas. Plus, but it doesn't matter for now. But let us just stick to the right thing, okay?
let's see this.
And also, don't multiply 4 times that stuff. First, find out what that is in terms of its raised to that index, or that index, and then multiply. But in this case, it's nothing but 4, because this is 0. Anything to the power of 0 is equal to 1. This is 0. Half to the 0 power is 1, so this answer is 4. This is going to be 1. Half of 4 is 2. Here you have a little problem. Here you have got 4, and then you have a half square, which is 4, and then a quarter. Now check. 1 times 1 is 1, 2 times 2 is 4. Which is just nothing but 4 over 4, which is nothing but 1.
Let me do it.
4, 2, what's going on? There's a plus sign, eh?
I can see it.
Does that make sense?
You can already see.
Is it an AP or GP? So it's a geometric series. First term is A, which is 4. The common ratio is 2 divided by 4, which is nothing but what?
It's in the bracket.
First term. Okay? So right, we just have to make sure we test it. So, S sub n, we are looking for the number of terms.
So it's a GP.
So,
It's a geometric.
n is the missing term. Alright. So we are going to use GP.
4
And let's just use A, and then we have 1.
minus
Let's take the R. What is our R? Is a half. Okay, let's take 1 minus R to the nth power of 1 minus R. So we don't know that, so but we know the first term is 4. Oh yeah, one of the biggest problems and mistakes that people do is when they are supposed to write the first term for A, they go ahead and write the common ratio. Here. So be very careful. That's why writing these things down is helpful. Write down your first term, write down your common ratio. Then, if you are looking for number of terms, n question mark, do you follow what I'm saying? Sum. We know the sum. What is the sum? The sum is nothing but this value here. 7n, 63 over 64. Does that make sense? Okay. So 1 minus, what is our common ratio? A half raised to the power of n over
1 minus
1 minus a half equals to 7. So that's the power. So we're going to have to use logs maybe or indices. Okay, so it becomes too technical. But here's the thing: 1 minus a half is a half, and 4 divided by a half is 8. I want 8. Take this answer. 0.5. Yes? Say 4 divided by 0.5 is 8. Are we together? Are we together?
Yes.
Okay. So I have now 8. 1 minus a half raised to n equals to, can we make that improper? Okay. What is 60? What is this as an improper fraction? Please use this button on your calculator. 511 over 4. Oh. So somehow something will become 512. That's 2 raised to the power of 8. So maybe n is going to be equal to 8. We'll see how it goes. But not really. Now we need to get rid of that 8. So we get rid of that 8 by dividing this answer by 8. Here's a little problem. Let's just finish this. What is 511 over 64 divided by 8? 64 times 8. Here. 64 is 4 cubed times 8. 8 is 4 times 2. It's 4 raised to the power of that times 2. 4 squared, 16 times 16 is 256. 256 times 2, 512.
I see.
You see it? The answer becomes 512. The whole answer becomes 512. Does that make sense to you?
Yeah.
Okay. Just checking. Just checking. So what is the answer? 512 over?
511.
Oh, okay. Just check. 511 over? Reasonable. Right. I just want to. I'm running out of space, right? So I'm going to subtract 1 from both sides. But here's the key. The 1 here is nothing but 512 over 512.
I see.
So I'm going to deal with a negative number there, which can be written as a power of a half with a negative in front of it. If we were using the formula the other way around, we probably would have this problem. That means our R will not be negative when we write it here. You understand that? So it doesn't mean just we have to be careful with that. But the answer should be exactly the same. Can I take this off?
Yes, sir.
Or I just want to continue with the that part. So 1 minus a half to the n power equals 511 over. So it's going to be a negative a half raised to the power of n. You see what I'm doing here? Alright? Let me just, so you don't get confused here. Okay? And then at 511 over 512. Now it's minus 1 because you're taking that 1 over.
Yes.
But this 1 here can be written as nothing but 512 over 512 because it's 1. Because I'm working with that. But you can use your calculator, you'll get the same answer. You're going to get minus 1 over, get minus 1 over 512. Now, can I take this stuff off here? 512 is nothing but 2 raised to the power 8. Remember I told you the answer is 8, right? You with me? Are you with me? The base is the same. Are the bases the same? Can I write this 8 here?
Yeah, anything. 1 raised to anything.
Is this 1 raised to anything?
It's just 1.
Now that we know what that is, we have answered the question. Therefore, the number of terms in the series that we had before
It's quite a nice
will
long.
be 8.
I like this.
So far, so good. You must write as we go along because I think I took away your question, but you know where it comes from. So everything else, I'm just going to do different ones here.
Answers?
I think this guy is made of something bad.
It's me. Not me. Just me. Plus
This is
one.
business.
You just say plus one.
What is 2 raised to the power of 8 though? It's just half of 512, it's 256.
I was going to say.
No, you're not. So what is 2 raised to the power of 10? 1024. There you go. Don't know. I was asking you what is this? If it's that, then this is nothing but 256 and this is nothing but 512. Stop sleeping. She's yawning here, and you see, like she's getting paid. Winning some sort of competition. Right, so look at the question, right? Our aim that we were looking for was the top number, the upper number of summation.